Okay, so in example 1, we found the inverse just by deducing what had happened. However, in this case, there's multiple things happening to x's at the same time. So it's much harder to think about what's happening and do the opposite. So here's how we can algebraically find the inverse. The first thing that we want to do, so algebraic steps. So our first step, we want to switch x and y. And then we want to solve for y. So the first thing, this is like my y, so I'm going to call that x equals y over y minus 1. In this case, our y is going to turn into the inverse. So the last step, we call y f inverse if it's a function. So sometimes our inverse is not going to be a function. So we can't use function notation if it's not a function. So let's see what happens here. All right, I'm going to try to get y alone. So first step, I'm going to multiply y to the other side. That's going to give me yx minus x equals y. I want to get all the y's together, so I'm going to subtract y over here, add x over here. I'm going to factor out the y. So now I get y is equal to x over x minus 1. Same thing. This is a function. It's a reciprocal function. So I'm going to call f inverse equal x over x minus 1. So we can test this. One of the ways that we've seen our inverses is when we looked at the log graph, and logs and exponents we saw were a reflection over the line y equals x. That's true for any inverse. So let's go have a look at this on Desmos. And we can test it a bunch of different ways. So first thing I'm going to do is I'm going to hope it loads. All right, so we had f of x was equal to x over x minus 1. And then instead of calling it f inverse, I'm going to call it g of x, x over x minus 1. And now, if they're inverses, f of g of x should equal x. And sure enough, that's the line y equals x. And if I test it again, g of f of x, I get the same thing. I get the line y equals x. Also, my original function, if I reflected it, so let's look only at the original, and let's look at the line y equals x. I'm going to make that a dashed line. Okay, so if we look at this, if I take this original function and reflect it over the line y equals x, well, this bit reflects over and comes down here. Same thing. This bit reflects and comes up here. So when I flip it over, it's really just going to be a mirror of itself. That's another way for me to know that this graph is its own inverse. So we have another one that's its own inverse. So a few different ways that we tested that that was correct. And again, algebraically, we switched our x and y's, solved for y, and if it's a function, we call it f inverse of x.